The only difference for these next couple is, we're in radians, but that's not going to bother you because you're going to change it into degrees. So what happens to 3 pi over 2?
Well, you got 270. Pi 180.
Yeah. So that's going to be, actually I want all of them, don't I? So that's going to be, pi is 180 divided by 2 is 90 times 3 is 270. So we're now looking at an angle of 270 degrees. So we're going to do exactly the same thing. We are on page 36, letter C. We're going to do exactly what we've been doing. And draw a circle. Well, actually, I'm going to plot my point. But my point's down here, right? 270?
Yes.
And so, since it's on an axis, we'll go ahead and draw a circle through that point. And then we'll figure out our x, y, and r values so that we can evaluate this. Because sine is y over r, cosine is x over r, and tangent is y over x. So if we know x, y, and r, we can figure all that out. All right, so let's see. Radius is 1. By the way, always positive. The radius is always positive. What about this point now? Here's the origin. I'm coming down 1.
0 comes
So 0, negative 1. So x is 0, y is negative 1. That makes sense to everyone? So then we just fill in. So the sine is y over r, which is just going to be negative 1. The cosine is x over r, which is just going to be 0. And the tangent is y over x, which will be undefined. Do you feel like you're managing?
Yeah.
All right, why don't you try the last one on your own? These are the zeros. So we're doing sine 0, cosine 0, and tangent 0. Now when you draw your picture, does everybody understand where 0 is? Where's 0? Right there. That's the starting point. Right there. That's the starting point. Q, what are the coordinates of this point? This is the what is the xy for this point? 1, 0. Yeah, that's exactly right. It's 1, 0. So x is 1, y is 0, r is 0. So go ahead and fill r is 0. What am I thinking? R is 1. Fill in your values. What'd you get for your sine?
I got 0.
0?
Yep.
You got 0, you're right. Cosine? 1. And tangent?
0.
Beautiful. Beautifully done. Anybody have an issue? All good. Ashley?
You still set up the same way, even though the degree is 0?
Yeah. Yeah, we still have, here are x, y, and r, and we still do y over r. The angle doesn't make any difference. The procedure, what's wrong with me? The procedure is the same.
How do you know where to put the point?
We're 0 degrees. When we label our angles, this is 0, this is 90, this is 180, this is 270, and this is 360 if I go all the way around. Okay, that's the way we've been drawing every single angle, right? So that's the framework we're going to use every single problem. Okay. All right, so that's not too bad. This next part is a little bit tricky. It's going to require you to do some thinking. So we're going to fight through this before we go to lunch. So we're finding the sine and the cotangent. That's our job. We want to find the sine and the cotangent. And what they give me, okay, so that's what I'm finding. What I know is that the cosine is 2/3 and the tangent is less than 0. Oh my goodness. All right, so let's think. Who has any idea about where we start? This is a different problem.
Cosine gives you
What'd you say?
cosine gives you adjacent for tan.
Okay, so cosine, so I could draw a picture. If I know the cosine is 2/3, I could draw a picture and label it like this. Would you agree with me?
Yeah.
That would be a picture for this right here. Now, in addition to that, the tangent has to be negative. This means negative, less than 0. Look at that triangle I drew. Will the tangent in that triangle be a negative number?
It could stick out.
No, you have to.
Not in that quadrant, right? Yeah. So I've drawn my triangle in the wrong quadrant. I got the right idea. That's exactly what I want that triangle to look like, but it's in the wrong quadrant.
Put it. I don't know what number it is. The one diagonal.
Because you have to find something that's less.
Yeah.
If I did my Pythagorean theorem, I'd have 2 squared plus x squared equals 3 squared. So 4 plus x squared equals 9. So I got √5 for over here. So what would the tangent be? I heard something really good back there. What would the tangent be? √5 over 2? Is that a negative number? No. So that's how I know I'm in the wrong spot. So I want that triangle. That is the right triangle, but I need it in a different quadrant. Can you tell me which quadrant?
Third.
Is he? 4. And why are you saying 4, Izzy? You are exactly right. Why are you saying that?
2 is still positive and the hypotenuse is always positive.
Bingo. She is putting all the pieces together. Very good, Izzy. She is saying, look, if the cosine is 2/3, then 2 has to be positive, because 3 is always positive. So 2 has to be positive. So if the 2's positive, then the √5 has to be negative for the tangent to be negative, and that only happens in quadrant 4. That's some serious thinking. This is the triangle I want, because it gives me a positive 2/3 and a negative tangent. So now I can answer the questions. What's the sign in that picture right there? That's the right picture. What's the sign? Negative √5/3. And what's the cotangent?
2√5/5.
So it'd be 2 over negative √5 or negative 2√5/5. We're gonna do one more. Hang on to your hats. We're finding the secant and the tangent. And this time we're told that the sine is 1/5 and the cosine is negative. Now what I like to do, and again, you guys get to decide how you want to do the problem, but I like to start out the way Brennan started that last one. He said if the sine is 1/5, then my picture has to look like that. Right? And I can go ahead and do my Pythagorean theorem. 1 squared plus x squared equals 5 squared. And I can figure out what that other side is. Let's see, what would that other side be? Did you get the square root of 24? Which is 2 root 6? Now that would be perfect, except this says the cosine has to be negative. This means negative.
That one is negative.
And in that picture, the cosine isn't negative, okay? But wait, if the cosine is negative, cosine is adjacent over hypotenuse, right? Then don't I need that number to be negative?
Switch over the y-axis.
So move it to quadrant 2, Anthony says. If I move it to quadrant 2, then this is going to be negative 2 root 6. Does that still have that picture? Does it still have a sine of 1 over 5?
Yes, it does.
And a cosine that's negative now?
Yes.
That's it. That's the one we want. There's 4 quadrants, so sometimes it takes you a few times to get the right one, but this is the one we want now. So secant. What will secant be?
Cosine.
Yep, it's a reciprocal of the cosine. So it would be 5 over negative 2 root 6. All right, I want everybody paying attention. Okay, so everybody got that written down? Negative 5 over 2 root 6. This needs rationalized. We've not run into this before. What you do is, that the part of this that bothers me is the root 6. So that's all I multiply by is the root 6. Now what happens when you multiply a root 6 times a root 6?
The roots drop.
You just get 6, right? But it's got times by a negative 2, so it's negative 12 in the denominator. Because it's the negative 2 times the 6 that comes out of the rationalizing. And then the top is just 5 root 6. And then you got the tangent. That's the other one we want to do with the tangent. What's the tangent? 1 over negative 2 root 6, which needs to be multiplied by root 6. So we get root 6 over negative 12. And again, that negative 12 is because these make 6 times negative 2. Got it? When we come back from lunch, we'll do one more of those. I think there's one more. And then, where's our graphing? Which we've been waiting to do. So I need you back at,
1.
what, no, not 1.
45.
49. You're back at 49. So, oh, Brendan, can you turn that off?
Yeah.
We don't need the videotape much.